Hi everyone, this is your struggling CS student. It's been a while since I've done one of these, so yeah, let's keep going. Let's take a look at today's problem of the day. Max sum of a pair with equal sum of digits. Okay, so apparently I've solved this problem before. It's a medium problem rated at 1300. So shouldn't be too bad, hopefully. So let's see, you are given a zero index array nums consisting of positive integers. Okay, you can choose two indices such that they are not equal to each other and the sum of digits of the number of nums of I is equal to nums of j. Note the maximum value of nums of I plus number of j they can obtain over all possible indices I and j that satisfy the conditions. Okay, let's go with some examples. The pairs ij satisfies the condition are 0, 2. Both numbers have a sum digit equal to 9, and their sum is this. And both numbers have a sum of digits equals to 7. Next one, and next for and their sum is this. So the maximum sum that we can obtain is that. Okay. There are no two numbers that satisfy the condition, so we return -1. Okay. Sum of the digits is equals to this. Yeah, I think it's not that bad. Basically, you can just keep track of the digit sum, and you just need to keep the two largest ones, right? And then you just get the maximum value that you can. That's one way to do it. What's the constraints? 10 power 5. Okay. Yeah, I guess that's it. So you just group them together based on their digit sum, and you could sort it if you want, or you can maintain like a heap data structure so that you only keep the top two. And I think that's it, I guess. I guess we can do the heap solution. I'm pretty sure there's like a better way of doing it, or like a smarter way of doing it. But yeah, default dig from heap queue, import heap pop, and hit push. So the idea is you have the digit sum map, digit sum to number map, right, which is a dictionary. Then you just go for num, nums. We need to have a helper function that helps us to calculate the digit sum. So get digit sum of a number. So you would say the result is equal to 0 and all num that's greater than 0. You get the last digit, that is num mod 10. And then num is equals to, then you will chop it off, divide equals to 10, and rest plus equals last digit. Then you get what's that? Oh, return rest. Right. So you just group them together. So digit sum of get digit sum of num, and you can just start append, or rather default dig of list. You can push it in, hit push into this heap of number, and we want to keep the top two only. We want to keep the top two only. So the length of, that means we want a max heap, right? Top two. We want a min heap. We want a min heap so that the larger items sink to the bottom, and we only want the last two, the top two biggest items, right? Because those are all the pairs to satisfy it. Yeah, I guess. So min heap works. If it's greater than 2, then we hit pop. This. Yep. Then for pairs, I guess. For num pair pairs. This is the digit sum. In digit sum to num map dot items, the result here, which is 0, result equals the max of pairs of 0 plus pairs of 1 max. Oh, no, this is res. Return res. Oh, big pop. Get digit sum, or like this. Okay, try run it. Runtime error. Oh no. Oh right. If length of pairs is greater than 1, because you could have the case where there's only one number that's mapping to the digit sum. So in that case, you won't want to set a default value here. It passes, but I'm not sure if like this is the smartest way of doing it. But yeah. Okay, what's the time complexity and the space complexity? Space complexity is definitely O(n), and the time complexity is O(n), and it's log n, so it's n log n. Actually, there's like n log n times log base 10, I think, because this is not exactly, or rather this function is not O1, it's like log 10. So yeah, so it's something like tc n log n, and this is log base 10, is log base 2. The space complexity is O(n), right? Am I confident about this? I don't know what edge cases I would miss, but numbers of I is only strictly positive. Okay. Okay, fine. Still, this thing is still nervous for me, man. But YOLO submit. Okay, accepted. Yay. Okay, I solve is a solve, but I want to see how I solve it in the past. That was quite a while back, actually. Let's see my first attempt. Space and time is also O1. Okay. N times M. Okay, the idea is essentially the same. So because there's only two values, then I technically don't need to use like a pop operation of the priority queue. I can just compare these two values and just pop the small index. So okay, fair enough. Same thing here. What do I do here? Reprocess it. Okay, let's see. Okay, with the digit in D, then we update the answer. If the current number is bigger than the number that we are storing, update it. So if we've never seen the same digit before, then insert it into the hash map, mapping the digit to its index. Okay, yeah. I see, okay. So we only store the largest one that we've seen so far, and if we've seen another one, we just try to add them together and then update the max as we go. Okay, yeah, that's also good. And this one was, oh, it's the same thing. Yeah. Yeah, it's just the same thing. Okay, so this is probably not like the best solution. Like there's no need for use of priority queue here. All right, let's see what the editorial writes. And log n priority queue. Oh, there actually is a priority queue answer of size 2. Oh, okay, cool. Let's see what about this solution. Given an array of nums. Okay, okay, yeah. Let's just see digit sum. Okay, calculate digit sum. These are pairs. You append the digit sum in this number. Oh, I see. Okay. Right. They sort it based on a digit sum, so they group them together, and it's also in ascending order. Okay. So you get the current and the previous, right? If they have the same digit sum, then you just calculate it. Okay. Yeah. That works too. Priority queue. Therefore, um, okay, that's the same idea that I had, but is this like maybe it's overkill? I don't know. Um, Yeah, calculate and push it in. If it's greater than 2, you pop it. Yep. And you just traverse in the map. And right, okay, fine. Yep. Okay, they pop it here as well. This is fine as well for a second. And not M. And what's M? M is the maximum number in nums. Oh, is my time and space complexity analysis incorrect? Expanded operation perform. Put nums. Calculate digit sum computes the sum of digits for a given number. It takes log m time. This is because the number of digits in a number is proportional to the log base 10 of m, where m is the maximum number. First layer is all n and computes the digit sum resulting in a total of n log m. Hit push. Okay, fine. You can say that this is like a constant operation. The hit push and the hit pop, which makes sense because there's only 2 elements. There's only 2 elements in the heap, so technically log base 2 of 2 it's it's constant, right? Yeah, because the size of the heap does not grow in proportion to the input. So then instead of saying that this function here is, sorry, rather the heap push function is log n, technically it's more correct to say it's O1 because it's constant. And then get digit sum is, well, log base 10 of m, where m is the maximum number in nums. So, okay. Space complexity is log m. Since the maximum data size proportional, okay, that's because they abuse this. Yeah, okay, sure. Anyway, just for maximum value over, right, this was the one of the few, how should I say? Wait, hold on a second. Oh, right, okay, yeah. First max, story maximum. Yeah, it's kind of like the approach here, right? Maybe this is not the best. Yeah, it's kind of like the approach here. N times M. Oh god. Okay. Yeah. Anyway, that's it for me. Let's see the time complexity analysis. Okay, fine. Yeah, that's it for me. Managed to solve this problem. This is the code here. Put it like this. Okay. Have a great one. Happy grinding.